So I want to talk to you in this video about data types in computer science. So data types are different ways that we can show values or use in arithmetic or statements or code or in just modern day world. Okay, so we've already this in key stage 2, we've already had a look at strings. Okay, so string might be the word or your name. It might be like Stan. An integer is a whole number, and we've looked at those in our programming. So that might be the number 17. A float is another word for a decimal, so something like 39.43. We've also used in our programs things like logic. So less than, greater than, equals, less than or equals, or greater than or equals to. Okay, and we've also used some arithmetic. You use that in maths and daily basis, and we also use that in code and other places as well. So we've got plus, minus, divide. We've got multiple, we've got things like modulus and so on there. Okay, we've also got something called Boolean. I'm not really going to talk about that, but that's something that we may use in searches or so on. Say, well, I want to search for carrots and onions because I want to make a carrot and onion soup, or I want to buy, I might search for trainers, but not Adidas. Okay, so it won't bring the Adidas results back. So that's Boolean. We won't be looking at that at Key Stage 3 too much. The areas I want to talk to you about are these ones here. Denary, binary, and hex. Now, denary is a numbering system that we're very familiar with. It's basically numbers between sort of 0 and 9. Okay, so if I wanted to give you a number of 421, that would be the denary values 4, 2, and 1. But the question is, how does a computer, okay, actually deal with those? So we've said in previous lessons, okay, that CPUs only understand binary. So what has to happen is that 52 has to be converted by the operating system and software into something called machine code. And that machine code fundamentally is zeros and ones. And we call that binary. Okay, binary only has two values, 0 and 1. So we can have 0, we can have 1, we can't have 2, we can't have 12. That doesn't work, okay? So the number 52 is converted into binary code. Now, how do we work that out? And you're going to be working that out in these exercises. So what we initially do, okay, to work out what is the binary of 52 is to make a grid. 1, 2, 4, 8, 16, 32, 64, and 128. Now, this has 8 columns, okay? This is what's called an 8-bit sort of operating system or 8-bit function, okay? And today, our computers are in 64-bit. They're much more, usually in 64-bit, sometimes in 32-bit. So rather than 8, in modern computers, we would have 64 columns. Okay, but let's just understand this bit. So how does it work? Well, what I do is I start at the end, okay, at the 128, and I said, do we need 128? No, so that's a 0. Do we need a 64 to make up the number 52? No. Well, what about 32? Well, yeah, that would be useful, wouldn't it? So far our calculation is 32, but we still need 20. So would a value of 16 be useful? Yeah, one of those. Okay, so that's up to 48 now, isn't it? Okay, so we've got 48, we need to get 4 more to make 52. Do I need an 8? Nope. Do I need a 4? Yeah, I'll have one of those. Do I need a 2? No, I've already got 52. So the binary value, when I type in the number 52, okay, on my keyboard, it would convert it into machine code into the binary value, if we're using an 8-bit operating system, of 00110100. Okay, so that we've just learned how to do denary to binary. But how